Hello, this is Matt from Heaney Apps, and this is part 6 in our 7-part full game tutorial series where I'll be teaching you how to make the full iPhone game 7 sides in Xcode using SpriteKit and Swift. By the end of this video, you will have a fully playable game because today we will set up the end of the game and running game over when a ball hits a side and the colours do not match. This will involve making the ball flash, playing a sound effect, making the whole game freeze for about 3 seconds, and then moving into a game over scene where we can restart the game and play it again. So by the end of this video, your game will look like this. Brace yourself, this is a long video, so let's get started and let's jump straight back into Xcode. Okay, so back into Xcode and back into our game scene.swift. So today we want to set up what will happen when a ball hits a side and the colours of the ball and the side do not match. So in 7 sides, this will be a game over. We already have a function in place from part 5 in this series called wrong match, and this will run when the ball hits a side and the colours do not match. So when there's been a contact, we are checking the match between the ball and the side, and if the ball's type and the side's type, therefore the ball's colour and the side's colour, if they don't match, we are running wrong match. So here in the wrong match function, we will set up what we want to happen when the ball and the side do not match. So here we will set up our game over. So far in this function, we're checking to see if we have set a new highest score at the end of the game, and if we have, we are saving our new highest score. We can now build upon this function to make the game end when the ball and the side do not match. So what do we want to happen when the ball and the side hit and the colours don't match? And therefore, what do we want to happen when it's game over? Well, we want this to happen. We want the ball to flash, to make it very clear the ball was hit the wrong side. We want a sound effect to play, and we want the game to sort of freeze for about 2 seconds before we are taken into a game over scene, which will show our score, our high score, and will let us restart the game. We want to start by making the ball flash when the ball hits a side and the colours do not match. So, we want the ball to flash, and we can do this with a number of actions running in a sequence. Now, just like when we deleted the ball, when the ball scaled down before deleting, what we would do, we will set up a brand new method for any object that is of type ball, which we will call flash. We can then run this method on any object that is of type ball to make it flash. So, into our ball object.swift, and here, we need a brand new method called flash. So now we can take any object that is of type ball and say .flash, and that ball will do any code that we have between these curly brackets. So when a ball runs the flash method, there's a few things that we want to do. Before we make the ball actually flash, we want the ball to stop doing anything else, which includes stopping the ball from moving. So when a ball runs the flash method, the first thing that we want to do is take the ball that we are running this flash method on and remove all actions. So when a ball runs flash, so the ball.flash, take that ball, stop it from doing anything that it's currently doing, so pretty much it will stop moving. What we also want to do before we make it flash is tell our code that this ball is no longer active in our game. This ball has now hit a side and therefore this ball is out of the game. And this is actually really important because without this we could get a bug in our code where if the ball was to hit 2 sides at the exact same time, so if the ball was to hit the joint of 2 sides together and one side's colour matched the ball and the other side's colour didn't match the ball, we'd get a bug in our game where the game would end because we've hit the wrong side, but we'd still earn a point and a new ball would spawn because we've also hit the correct side. So with this, that will eliminate that bug. So now that that's taken care of, we can now move on to making our ball actually flash. And to make the ball flash, all we have to do is run 2 actions on this ball. We have to make the ball fade out and fade back in. We will run these in a sequence, so the ball will fade out entirely and then fade back in. We will then make this sequence repeat 3 times on the ball, so the ball will fade out, fade in, fade out, fade in, fade out, fade in, to get a nice flash effect. So in the flash method, we will say let, and we will create our first action called fade out, being skaction.fadeout with duration of 0.4 seconds. The other action is fade in, and this will be fade in with duration. So we now have these two actions, fade out, which will make an object fade out across 0.4 seconds, and an action fade in, which would make an object fade in across 0.4 seconds. We want to have these in a sequence, so let flash sequence being skaction.sequence, and remember, a sequence is a list of actions that we want to run one after the other. So we want our square brackets, and in here we will say if any object runs the flash sequence, we want that object to fade out entirely and then fade back in. So now any object that runs a flash sequence will fade out and will then fade back in. So that would make the ball flash once, but we want the ball to flash 3 times, just to make it really obvious that the ball was hit aside and the colours do not match. So we need one more action called repeat flash. This being skaction.repeat, not repeat forever. We don't want the ball to keep flashing forever. We only want it to happen a certain number of times. So skaction.repeat flash sequence 3 times. So now any object that runs repeat flash will run flash sequence, so it will fade out and then fade back in 3 times. So now any object that runs repeat flash will fade out, fade in, fade out, fade in, fade out, and fade in. Then all we have to do is take the ball we are running the flash method on and run repeat flash. So self, so the ball we are running this on, dot run repeat flash. So now we can take any object that is of type ball and we can say dot flash. That ball will stop moving entirely because we have removed all of its actions. We have told our code that this ball is no longer in the game by setting its isActive property to false, and we have then made the ball run repeat flash. So the ball will fade out and then fade back in 3 times. So the ball will fade out, fade in, fade out, fade in, fade out, and fade back in. And that is our flash method. So Command B to build this. Back into our gamescene.swift. And now back into our wrong match function, making sure we're after the if statement for our highest score. Very important we're not in the if statement. We want to make the ball flash. Now for this, what we have to do is when we run the wrong match function is pass the ball from the contact into this function. So we set this function up in the previous video for our highest score, but now we have to change this just a little bit to say when we run the wrong match function, we have to pass in a ball so we can affect it. And now all we have to do is when we run the wrong match function from our check match is pass in the ball from the check match function, therefore the ball that was in the contact. So remember, when there has been a contact, we're passing the ball and the side from the contact into our check match function. We're now taking the ball and passing that into the wrong match function so we can affect the ball that was in the contact. It just keeps it all nice and organized. So now in the wrong match function, we can affect the ball that was in the contact by affecting ball from here. So all we have to do is take ball and say dot flash. This will take the ball that we're being passed into this function, therefore the ball that was in the contact, and make it do all of the code in flash. This will make the ball stop moving. It will set the ball's isActive property to false, so it's no longer in the game, and it will then flash 3 times. So let's hit run and let's have a look. So now if we start the game, let's get a few points. And then let's get one wrong. The ball is going to stop and the ball is going to flash 3 times. So now it's very clear that the ball was hit the wrong side because it flashes 3 times. So that is starting to come together very nicely. Now the polish is off. Just like when we score a point, we want to play a sound effect. So back into our game scene. So the first thing that we have to do is get a sound effect and drag it into our project. The sound effect that I will use is here on my desktop, and there's a link down in the video description where you can get this sound effect. This once again is a free sound effect, and full credits for this sound effect can also be found down in the video description. So once you have a sound effect, we will simply drag this into our project over here on the left. We want to make sure copy items if needed is ticked, and add to targets is ticked. Hit finish, and we now have the new sound effect in our game, and we want this sound effect to play when the ball hits a side and the colours do not match. And this sound effect sounds like this. Okay, so back into our game scene. So all we have to do is set up and run an action to play this sound effect in the exact same way that we did for our sound effect in the correct match function. So we have to start by globally in the game scene, declaring a brand new action called play incorrect sound. This will be an skaction.playSound file named, and we want to play incorrect sound.wav. And once again, if you ever wanted to rename your sound effect, just click it and push enter and you can rename it. So name it something nice and easy to type into your code. Wait for completion will not affect this action at all because we're not running it as part of a sequence. Then all we have to do, when the ball hits a side and they do not match, take our scene and run play incorrect sound. So now when the ball hits a side and the colours do not match, the ball is going to flash and we're going to play this incorrect sound effect. And just with that, we now have the sound effect. So let's hit run and let's have a look and start the game. And if we score a point, we're going to get the sound effect that plays when the ball and the side match. But if the ball and the side do not match, we will get the new sound effect whilst the ball is flashing. Very nice. That's all working fine. So we now have the ball flashing when it hits the wrong side. And what we want to do is when the ball has finished flashing, we want to change scene into our game over scene. But before we can move on to set up our game over scene, there's a few more things that we have to polish off here. Because even though the ball is flashing and our sound effect is playing, we have a few bugs still in this, and something that we want to polish off. So the first thing is, when the ball hits a side and the colours don't match, we can still spin the colour wheel, like so. And this will happen when the ball is flashing. So let's have another quick look. Let's hit run again. So when the ball is flashing, we can still spin the colour wheel. And that obviously isn't really what we want to do. So we want to say when the ball is hit aside and the colours don't match, we will not make the colour wheel spin if we tap on the screen. So back into our game scene, and this is another one of those things that will be very quick to do because of the way that we have set up so much of our code. So as you may remember, we have a variable which is telling our code what the current game state in our game is. Are we before the game or are we in the game? We're then saying, when we touch the screen, if we're before the game, start the game, but if we touch the screen when we're in the game, spin the colour wheel. All we have to do when the ball hits the side and the colours do not match is tell our code that we are now after the game, so therefore don't let us do anything. So for this, what we have to do, we have to jump back into our models and data, and we have to find our enum for our game state. And here, as you may remember from all the way back in part 3, we have the different options that anything that is of type game state can be. So just like a boolean has to be true or false, anything that is of type game state has to be set to before game or in game. Now here, we want to add a brand new option called after game. And this will be used for the few seconds when the game has finished, where the ball is flashing, but we have not yet moved into our game over scene. So with this new option, what we can now do is hit Command B quickly, back into our game scene. All we have to do when wrong match runs, so when the ball hits a side and the colours don't match, is take current game state, the variable that is telling our code what the current state of our game is, and set this to after the game, our brand new option. So now when this code runs to end the game, current game state will be set to after game, And that's all we actually have to do, because in the touches began, what will now happen is when we touch the screen, current game state will not be set to before the game, so we won't start the game, and current game state won't be set to in-game, so we won't spin the colour wheel, so nothing is going to happen. So as our current game state is set to after game, because the game is finished and the ball is flashing, and we're about to move into our game over scene, we are no longer before the game, so don't do this. We are no longer in the game, so don't do this. Therefore, nothing is going to run. And we've done that by simply setting current game state to after the game, our brand new option. So let's hit run and let's check that's working. So now if the ball hits a side and they do not match, it's going to flash and we cannot spin the colour wheel anymore. So the game will sort of freeze apart from the ball flashing. Awesome. So we now only have one very small thing that we have to do here in the game scene, and then we can move on to set up our game over scene. And what we want to do is say that when the ball hits a side and the colours do not match, is we want to take the colour wheel and we want to stop the colour wheel spinning if the colour wheel is mid-spin when the ball hits the side and the colours don't match. Because otherwise what could happen is, I'm gonna have to try and time this right, but what could happen is that the ball could hit the side and the colours don't match. But as we've touched the screen, just before the ball has hit the side with the wrong colour, the colour wheel is still going to spin. And it could all happen so fast that by the time the colour wheel stops, it looks like the ball has hit the right side, even though the game is going to end. I'll try and show you what I mean. So just like that, the pink ball hit the red side, but because the colour wheel was mid-spin, the colour wheel continued to spin, the colour wheel finished its spin, and now it looks like our game has a bug, even though what's really happened is the pink ball has hit the red side first to trigger game over before finishing its spin. So to prevent that, all we have to do in the wrong match function, as the ball is flashing, we're playing our sound effect, we are changing our game state, we have to take our colour wheel base, that big red square, which we are spinning to make the colour wheel spin, which I'm sure you remember from all the way back in part 1 and part 2, take the colour wheel base and remove all actions. So now if that colour wheel base is mid-spin when there's been a contact and the ball and the side do not match, stop the colour wheel exactly where it is. So now if the ball was to hit the wrong side mid-spin, this would happen. The colour wheel is going to stop mid-spin whilst the ball is flashing to completely eliminate that problem. So now when the ball hits the side and the colours don't match, the ball is going to flash, we will get our sound effect, we can no longer spin the colour wheel, and the colour wheel is going to stop in place when the ball hits the wrong side. And that is the end of the game here in the game scene. So what we now want to do is say once the ball has finished flashing, take us into another scene. This new scene will be our game over scene. It will say the words game over, it will show us our final score, it will show us our high score, and it will let us move back into the game so we can play it again. So back into our code. Okay, so we now want to make our game over scene. And this will be a completely different scene to what we have here. So what we can do, we can make multiple scenes, which are pretty much separate from each other, and then in our game we can just transition from one scene to another. So we want to make a brand new scene that will look like this. This scene will have the same background. We have our colour wheel. This colour wheel here will be just one sprite node as our logo, because this one here won't really do anything. And we need some labels to show the words game over, to show our score, to show our high score, and to tell the gamer to tap the screen to move back into the game to play again. So what we could do is make a brand new scene and create this entire thing through code. Because all this is effectively a couple of sprite nodes and a few label nodes. That's all it is. We know how to do all of that already. But instead, what we will do, as I promised all the way back in part 1, I know it was quite a while ago now, is we will use an SKS file to build this scene. And an SKS file is almost a drag and drop scene builder. So we can literally just drag images and labels and anything that we need into an SKS file, which will build and design our scene. We can then link this to our code to make it do something. So that's what we're going to do. We're going to use an SKS file to build up our game over scene. Before we start doing that, quick fair warning. There's this weird bug that you can randomly get sometimes in some projects in Xcode, where a pretty major part of using an SKS file just doesn't work, for just about absolutely no reason. There's a pretty easy workaround and a pretty easy fix for this. And if you don't get this bug here in this project in Xcode, there's a chance you will get it in a future project. So later in this video, whilst we're using the SKS files, we will take a look at what this bug is and how we can work around it. So we will set everything up in the proper way. We'll then check to see if this bug in Xcode will affect this project here, and if it does, I will show you how to fix it. Chances are it will only affect a very small number of you, so we'll see how it goes, but either way we'll have a look at what this bug is and how we can fix it. So, to build a scene with an SKS file, we need two new files. One file will be our SKS, where we can drag and drop to design the scene, and one code file. So here in Xcode, we will go File, New File, and we will go iOS, and we will scroll down, and we want a sprite kit scene. Be careful not to do a sprite kit action or a scene kit scene. We want a sprite kit scene, a scene builder for a 2D game. Hit next, and we will call this game over scene, and hit create. This will make us a brand new SKS file, a sprite kit scene file. So game over scene.sks, and we will get this. What we might have to do is zoom out using the minus button at the bottom of the screen, and we want to zoom out enough so we can see the entire outline. So this is the base of our SKS file, and in a moment we will set our scene up here, and we will simply be able to drag and drop what we need onto the scene. But before we do that, there's one more file that we need, which would be the code for this scene. So again, we will go File, New File. This time we want an iOS Swift file, hit next, and again call this the game over scene and hit create. This time we will get a game over scene.swift file, and we will get an empty file for our code. So we now have our two files. We have our SKS file where we can build up our scene, and our .swift file where we can code what we want this scene to do. Now before we move on, we want to link these two files together so that our code knows what we build here in this SKS file will be linked up to this code here in the .swift file. So into our gameoverscene.swift, the first thing we have to do is import SpriteKit, so we can use all of the cool stuff that we can do with SpriteKit, and we will set this file up as a scene. So we will say class game over scene, and this will inherit from SKScene. So game over scene is a scene that we can use in a SpriteKit game. So this has taken this file and told our code we want to make a brand new scene called game over scene. We can now link this code to our SKS file. So Command B to build, and into our gameoverscene.sks. Let's click on the scene, and over here on the right, in the fourth tab along, in custom class, here we say what code we want to use. So here we have to say game over scene. This will tell the SKS file to use the code in the game over scene class, which is our SKScene. So here we will say game over scene and push enter. This will now link up this SKS file to that code. Now this might be just for me on my laptop, but sometimes changes that you make, like this here, don't always get saved as we push enter and as we build through our project. So what we're going to do to play it safe, we will push Command B to build. This will build our entire project. Then whilst we're in the SKS file, we will go File, Save. And this, I found in the past, will lock everything in for you. Okay, so we now have our SKS file set up, and it's linked to a code file. And here, we will build up our game over scene. So the first thing we want to do is make our scene in the right size so we can work with our scaling down universal game technique that we've been working with the entire time in this project. So to do that, we will click on our scene, over on the right, third tab along, and we will change the width and the height. Now, as you may remember from all the way back in part 1, our game scene has a size which has a width of 1536 and a height of 2048, and we want our game over scene to be the same size. So width will be 1536, height 2048, and this will now make our brand new game over scene in the correct size. We're going to have to zoom out again, or you can scroll and try and get the entire scene onto your screen. So now we can build up our game over scene here. However, before we actually build our game over scene, I want to test what we've done so far. So before we add all of the bits that we need to our game over scene, we instead will deal with moving to this game over scene when the game has finished. So Command B to build everything, and back to our game scene, and back to our wrong match function. So all we have to do here is say to our game, move us into our game over scene. However, we don't want to just trigger the code to change scene straight away, because remember, the ball is flashing, and when the ball flashes, the ball will fade out and then fade back in 3 times. So the ball will take 0.4 seconds to fade out, then 0.4 seconds to fade back in. So one complete flash is 0.8 seconds. So the complete flash sequence where the ball will flash 3 times will take 2.4 seconds. So we want to wait at least 2.4 seconds after the ball was hit the wrong side before moving into the game over scene. Otherwise, the scene will change as soon as the ball hits the wrong side, and us doing everything that we've done so far in this video wouldn't be seen, and that would have been a complete waste of time. So back into our game scene, back to the wrong match function. So here, we want to tell our game to wait for at least 2.4 seconds before changing scene. Now what I'm going to do is make my code wait for 3 seconds before changing scenes. So the ball will flash, it will flash 3 times, it will finish flashing, and then there'll be a slight pause before we change scene. But if you didn't want that slight pause at the end, when we set this up, just work with 2.4 seconds rather than 3 seconds. Okay, so to do this, we will run a sequence of actions on our scene. So the first action we want will be to tell our scene to wait. So let wait to change scene be an SK action dot wait for duration 3 seconds. So here we would tell our game how long we want to wait before we change scene. So we want this action to run, and then we want another action to run to change scene. Now there's not really an action to change scene, but what we can do, we can set up an action to run a block of code, which is perfect if we want to set up a delay before running some code. So we want another action called change scene. This will be an SK action dot run. We want the one with the curly brackets, like so. So now any code that we have here between these 2 curly brackets will run when we run this action. So here we will set up our code to change scene. Then we can set up a sequence which will run this action to wait for 3 seconds, and then we'll run this action to change scene. So here we want the code to change a scene. To change scene, we have to tell our code what scene we want to move to. So let scene to move to. And because we're going through an SKS file, we will say scene to move to is an SK scene, open bracket, file named. If we weren't doing this with an SKS file, this would be a little bit different, and you will see the code for that when we move from the game over scene back to our game scene. So here we say what scene we want to move to. And we want to move to game over scene.sks. So here we say take us to an SK scene, which is in the file game over scene. No .sks, just game over scene. Make sure you spell this completely right and with the same capital letters. And what we have to do, we have to force unwrap this like so, because this is an optional and our code does this in case it can't find the file. So it's almost a safety procedure for our code, but we know our game over scene is definitely going to be there. So we're going to force unwrap it. And this is one of those things where I don't know if I'm looking at this in the wrong way, but people sometimes tend to keep these as optionals for safety because of the reasoning that if for whatever reason your code can't find the game over scene, it will just not show a new scene. If we force unwrap this, if we can't find this, it will make our code crash. Now, I'm all for code safety, but for whatever reason, if my game couldn't find the game over scene, something's gone very wrong. I would want it to crash rather than just show nothing. That's almost worse than crashing. So this way, we're saying this file will definitely be there. If it's not, the game will crash, but that won't happen to us because we know game over scene is going to be there. We got to set this scene up, but most of setting this scene up is done through the SKS file, including setting up the size. So all we have to do is set the scale mode, and the scale mode will set how zoomed in the scene is. We are working with a normal scale mode, so we will set the scale mode of the scene we're moving to be the same as this scene's scale mode, just so we don't get any nasty surprises. Because if we don't say what scale mode we want to use, I found in the past that it can give you a completely different scale mode for your new scene, and that would make the scene that you're moving to look pretty weird. We want to move to this scene with a transition, so let scene transition, this will be an SK transition, dot, and we just want fade with duration across 0.5 seconds, and then all we have to do is tell our game to go to this scene. So we will say self, and we want to be dealing with the view that is presenting us our scenes. So self.view, we have to unwrap this, we know the view is going to be there, so that's fine. Dot present scene, and we want to move to scene to move to, which remember is our game over scene SKS file, using our transition scene transition, this from here. So now, when this action runs, any code between these two curly brackets is going to run. And here we're telling our game to take us to scene to move to, which will take us into the scene that we will build through our SKS file, game over scene. We set up our scale mode to make sure this scene is presented in the same way as this scene, to make sure it's not too zoomed in or too zoomed out or stretched or any of that. And we will move there with a transition, so our game scene will fade out and our game over scene will fade in across 0.5 seconds. So we said present us our new scene using our scene transition. So that's the code to change scene to a scene that's been built through an SKS file. All we have to do now is set up a sequence so we can run this action to wait 3 seconds and then run the code to change scene. So after this closing curly bracket, which will close this code for this action here, very important it's outside of this closing curly bracket, we will say let scene change sequence be an skaction.sequence, so a list of actions that will run in order, one after the other. Remember your square brackets because it's a list, so it's an array. And we want to run wait to change scene, so we get our delay, and then change scene. Then all we have to do is take this scene and say run the action scene change sequence. So now our scene will do this. So our scene will wait for 3 seconds and then we'll run the code to change scene. So now when the ball hits a side and the colours don't match and the game ends and the wrong match function is going to run, we are checking to see if we have set a new high score, the ball is going to flash, the sound effect will play, we have changed our game state so the gamer cannot spin the colour wheel, we have stopped the colour wheel if it's mid-spin, and we are now telling our code to wait 3 seconds and then change scene into our game over scene. And that will move us into our new scene when it's game over. So let's hit run and let's have a look. So let's start the game. Let's hit a wrong side. The ball was going to flash, be a slight pause, I'm going to move into our new scene. So this here is our game over scene. There's nothing there yet, but this is our game over scene. So let's build up what we want our game over scene to look like. So back into our game over scene.sks. And as you can see, what we had here as our game over scene is what we could see in the simulator when we changed scene. So now all we have to do is drag what we want onto the scene here and build up our game over scene. So for our game over scene, the first thing that we want is a background. So for a background, all we have to do is over here on the right, down here at the bottom, third tab along, we will find what kind of object we want for our scene. And there's so many we can drag on and play with, but the one that we want for a sprite node is a color sprite. So let's drag a color sprite onto our scene, making sure the color sprite is selected. Over here on the right, third tab along, texture is going to be game background, our background, and we will drag this to cover our scene. Use the yellow lines as markers, like so. And just with that, we have our background. So we just dragged our object on. We wanted the sprite node, so we used a color sprite. We dragged it on and set which texture we wanted. So now if we click on the background, over here on the right, again in the third tab along, we can set a whole bunch of values, just like we can do through our code. We can change the position, we can change Z position, give it a starting rotation, change its size, change its anchor point, its scale. So anything we could have set through our code, we can set here. Now you might notice the background's position is 0, 0. And that is because by default here in an SKS file, 0.00 is actually the center of the scene rather than the bottom left of the scene. Now you can change that by changing the scene's anchor point to 0, 0, but we have no real reason to change it as we will simply just be dragging stuff on anyway. So that's why the position is 0, 0, the center of the scene. Now the one that we do have to change for our background is to remember to change our Z position to be -1. Just like when we set up our background in our game scene way back in part 1, we set the Z position to be -1 for a background because this is all to do with the layers. Every object defaults to have a starting Z position of 0, and by setting the background's Z position to be -1, we are guaranteeing the background is always behind all other objects. So simply by dragging this color sprite object, so a sprite node, onto the scene, setting the texture and setting the Z position, we've added this object to the scene. We now want our logo, so another color sprite onto the scene. Texture for this one will be the game logo, which will be the color wheel, but because this color wheel won't do anything, we can just use a standard picture rather than building it all up through code. And we'll drag this, position it wherever you really want. That's the cool thing about the SKS file, is that we can literally see the scene as we're building it, so you can get it exactly as you want without having to rerun it and checking it every time. Quick note, as this game is universal, this scene has been built in the aspect ratio of an iPad. So on the iPhone we will lose some of the sides, so don't go too close to the sides. If when you run this and check this out on a simulator, if part or all of an object is missing on an iPhone, that is why. We will see this entire scene on an iPad, but on an iPhone, we only really see the middle part. So you don't want to be going much further left or right than where this color wheel is. In fact, I'll quickly show you. So you see how much room we have here in the SKS file. If we was to hit run, on an iPad, we would see this entire thing. But as we're working on an iPhone for now, we don't have that much room down the sides. Okay, so we now have our background and our logo. We now want some labels. So down to the bottom, we will find a label and we will drag this on. And over here on the right, we can set this up. Now we're going to be dragging our label to where we want it to be. So the main ones that we really care about are the text, the font and the color. So this label will say game over. For the font, if we click on this T here we can set up what font we want to use and the size. Now we want to use a custom font. And we have a custom font all set up in our project that we prepped a few videos ago. So we set up the custom font Caviar Dreams in our project. But to be able to use Caviar Dreams in an SKS file, not only do you have to do everything to prep the font in the project, you have to install the font onto your Mac. So find caviardreams.ttf, right click Show in Finder, open up the TTF file, and we will go Install Font. Mine's already installed, but hit install, let it install, back into Xcode, then we have to come out of our SKS file, back into our SKS file, find our label, either by clicking on it here or over here, and back into our font, and now Caviar Dreams should be on the list. There it is. So we want our labels font to be Caviar Dreams, font size of 150, like so. And now we have to set the font color. So find color, open it up, and we have a whole bunch of colors here that we can use, but we will drop all the way to the bottom to other. And here we can have a lot more control over what color this label is. And we have a whole bunch of different options that we can use. So we want this label's text to be the same color as what we've used for all of our other labels. So for this, we will use an RGB color. We're going to set the red, the green and the blue to get the right color. And what we will do, we will set the red to 85, the green to 85 and the blue to 85. This color here. So we now have our label. Let's drag it into place. Now we want 3 more labels, which is done pretty much in the exact same way. So another label. This label will show our score. So for now, it will say score:0. We will make it show the actual score through our code in just a little while. Font, again, will be Caviar Dreams. Font size of 100 and the same color. We want another label very similar. And if we ever want a label that's really similar, if we click on the score label, hold Alt on your keyboard and just simply drag down. And the only thing we want to change is this label will say high score and this label will show our high score. Again, just make it say 0 for now. We will deal with showing our high score through our code. And then one more label, which we'll just drag down again. This one will say tap to play again with a font size of 75. It's a little bit smaller. And just drag it around to whereabouts you want it. So have a play around with where these are and make it exactly as you want. So we've now designed our game over scene. And this is all of the things that we need for our game over scene. So by simply dragging and dropping, we have pretty quickly made a background, our logo and our labels. And this has saved us a lot of coding just to make all these objects. Because this is our game over scene. There's a few things in code we have to do to make it work, but in terms of designing our game over scene, that's it. So now if we was to hit run, and if we get game over, we'll get taken into our game over scene, and here we'll have our background, our logo, and our labels in the exact way that we want it. So the SKS file can be a really quick way of building up scenes. But I hope you agree that it was the right thing to do for us to make the game scene entirely through code, rather than dragging objects on, because hopefully you guys learnt a lot from building up that game scene through the code. But that is how we can build up a scene through an SKS file. The problem is, at the moment, it doesn't really do anything. And in the game over scene will just show a score of 0, a high score of 0, and nothing happens when we click on the screen. We now have to run some code in this scene to make it work the way that we want it to. And as I'm sure you remember, our scene is linked up to our game over scene. So now we can make this scene do what we want it to do here in the game over scene. So what code do we need for our game over scene? Well, we need code in place which will show the game's final score in the score label. We need code that will show the high score in the high score label, and we need code to move back to our game scene when we tap on the screen so we can play the game again. Now before we do this, we have to check something over, and this I feel is the biggest pain, if you will, around using an SKS file. Because sometimes, and I think it's quite rare, it's only happened to me a few times, we get this bug in Xcode where even though we have made our SKS file and we've made this code file and it's all linked together, sometimes our project just completely overlooks this. And it's really frustrating because there is a workaround if this happens. But as far as I know, there's no logical reason for it to happen. It's just a weird bug in certain versions of Xcode that causes this to happen sometimes, you know? And I've researched this quite a bit in the past to try and figure it out. And everyone just says it's a bug in Xcode. So I'll show you how we can test this, and I will show you how we can work around it if this bug is happening to you, where this code here simply isn't being linked up to our SKS file. because if you're working on your own projects, there's a chance this bug is going to happen to you, and it is a pain. So I wanted to explain to you this bug and show you how we can fix it in case it ever comes up for you. So we want to make sure this code here is in fact linked up to our SKS file, just like we said it should be. So when we move into our SKS file, as this SKS file should be linked up to that code. When that SKS file loads up, our did move to view here in this game over scene is going to run. So here what we will do, we will simply print a message that will say the code is linked up to the SKS file. Now, when we move into our SKS file, this message should print. If it does print, the SKS file and this code here is all linked up properly. But if it doesn't print, then this bug is causing us a problem, as this code has not been linked up. And for the vast majority of you, it should print. But in some projects, for whatever reason, this bug in Xcode will make the code not link up. And it's such a silly bug, you could literally drag and drop all your files in this project into another project and it would work fine. So let's have a look, let's hit run and let's see if it's all linked up. Hopefully mine's linked up. I'll show you how to fix it either way if it's not linked up. So let's get game over. And hopefully, yeah, see, mine's not linked up. And my message here isn't printing down to the log. It's just a weird bug in Xcode and it's quite frustrating. If it's not linked up, first thing to do, make 100% sure here in the SKS file, you're linked up to your game over scene and you have saved it. And then the workaround is when we move into this scene, so in the game scene, rather than saying create an SK scene, we will say go to our game over scene here and use the SKS file. I'll be honest and say I don't know the pros and cons of doing it this way, but from my learning, it looks like it's best practice to create the SKS file and link it all up through the SKS file. But if it's not linking up, this here will fix the bug in Xcode. So if that bug is happening for you, do it this way. If not, say SK scene here, do it in the way that appears to be correct. So now, with that, if we hit run, and then move into our game over scene, as you can see, now it's all linking it up. So make sure, whether it was doing it the right way, if you're not getting this Xcode bug, or you're getting it now, just make sure this is printing here, because now our code is linked up to our SKS file. So now we can do what we have to do to our scene here through our code. So now with that out of the way, we can now finally make our scene work in the way that we want to. So we want to start by showing our score in the score label. So we want to take this label here and we want to affect it through our code. So we have to link this label in the SKS file up to some code. And to do this, what we do, we click on the label, make sure you're on the label, not on the background. Over on the right, we go on the third tab and we use the name property. So we will give this a name of score label. Push enter and again, make sure it's saved. It should do it for you, but the SKS files in Xcode can be very buggy. So now that that has a name, we can affect it. So what we want to do as soon as the scene loads up, so here in our did move to view, we want to change that label's text. So what we have to do, here in the did move to view, we have to take this label, link it up to a variable or a constant so we can affect it through our code. So what we will do, in the did move to view, we will say let score label of type sk label node. So we've declared a new constant called score label, which would be an sk label node. And we want to link this here up to our label in our SKS file. And to do that, we say to our code, go look at all of the objects on this scene, find us one with a certain name and set that to this score label constant. We can then affect this score label constant and affect the label. So we will say equals self.child node with name. So find an object on the scene with the name score label. Okay, and that is what name this label has. So this will take that object and set it to score label. Now at this point, our code doesn't know that this object is an SK label node, so we have to say this will be an SK label node. This will take that object, which we gave a name property of score label, and set this to score label. Now, if we affect score label, we affect the label. So we will take score label, and all we have to do is set the text to say score, and then show the value of the score integer. Now remember, this score integer is keeping track of our score throughout our game, and we are adding 1 to it every time the ball hits the side and the colours are the same, and we can get access to this because we declared it in our models and data. So now we have linked up that label in the SKS file to score label, and we are changing the text of score label to say score and then show the value of our score. Let's hit run and let's have a look. Let's score a few points. And let's get game over. So we got 2, and as you can see, our label here on game over is now saying score 2. Because this label through the SKS file is now linked up to our code, and we're changing the text to say score and then to show our score. Same thing for the high score label. Click on the label, we will give it a name of high score label, enter and save. Into our game over scene.swift, we will declare a constant called high score label of type SK label node, and this will equal the object with the name high score label, and we'll treat this as an SK label node. Again, in the SKS file, we gave that label a name of high score label, and we have told our code to go look for an object on the scene with the name property high score label, treat this as an SK label node, and set this to high score label. So now all we have to do is show our high score in this label. So to do this, the first thing that we want to do is grab our high score from our user defaults, just like we did when we loaded up our high score in our game scene. So high score equals whatever we have saved in the user defaults as high score saved, which, as I'm sure you remember from the previous part, is where we are loading our high score from. And if we set a new high score, where we are saving this new high score to. So basically, high score saved in the user defaults is holding on to our high score. So now the constant here, high score, will be set to the high score we have in our user defaults. All we have to do is take high score label, change the text to say high score, and then whatever our high score is set to. So this will take our label, it will link it up to high score label in our code. We have then reloaded up our high score, and we have then said show this high score in the text of our high score label. So now both our labels in our SKS file should be linked up to our code, and both should be showing the text that we want. So let's score some points. Let's get game over. And as you can see, it says our score was 4 and our high score is 9. Beautiful, our labels are now working. All we have to do now is say when we tap on the screen, move us back into our game scene so we can play it again. So for this, here in the game over scene, we will set up our touches began. So what do we want to happen if we touch on the screen when we're in the game over scene? And here, all we have to do is move back to our game scene. So if we tap anywhere on the screen whilst we're in the game over scene, let's move back into our game scene. As the game scene is not built using an SKS file, this will be a little bit different to when we moved into our game over scene, but it's very similar. So the first thing we have to do is say what scene we want to go to. So let scene to move to. We want to move into our game scene class. And here we will say how big we want to make this scene. Because this scene hasn't got an SKS file, it doesn't know how big this scene should be. So here we will say take us to the game scene, this name from here in our game scene.swift, And as we want to use the same scene size as this game over scene, because all of our scenes are the same size, we can just say, take us to the game scene, and set the game scene size to be the same size as the game over scene. We have to give this, once again, a scale mode, the same as this scene's scale mode, to make sure nothing is too zoomed in or too stretched. Then again, we have to have a scene transition. This be an SK transition. Again, fade with duration of 0.5 seconds. And then take the view dealing with presenting our scenes and present scene to move to using scene transition. So now, if we touch on the screen when we're in the game over scene, take us to our game scene through our code and make this game scene with a size the same as the current scene's size. So all of our scene sizes will be the same, but we have to say how big this scene is going to be anyway. We're taking care of the scale mode again to make sure everything stays the same. Nothing's too zoomed in, nothing's too stretched out. We set up a transition, so our game over scene will fade out and our game scene will fade in. And then we said take us to scene to move to, which is our game scene with the size and the scale mode, using our fade transition. And just with that, if we now touch the screen when we're in the game over scene, we will get taken back into our game scene. There's one more very small thing we have to do in this video, so don't go rushing off just yet. But let's quickly test this. So score some points. Try and get a high score. I got 8, high score of 9. We get taken into our game over scene. It will show our score is 8, our high score is 9. And now if we tap the screen, we get taken back into our game scene where we can play again. There's one more thing we've got to do, because at the moment, if we play again and we score some points, as you can see, our score carries over from last time. So I started straight on 8, my score from last time, and the difficulty system starts the same as it was. So the balls start going pretty quick straight away. So what we have to do, because we declared our score and our ball movement speed in the models and data, because we use them all over the place, and we update these values as we go, we have to make sure these are set back to a score of 0 and a ball movement speed of 2 every time a new game starts. So very important that score starts off at 0 and ball movement speed starts off at 2. So in the game scene, in the did move to view, the very first thing we want to do when the scene loads up is make sure score is set to 0 and ball movement speed is set to 2, so the ball has the correct starting movement speed. This will set these values back to their starting value to let our game begin again properly with fresh values. And just with that, we will now have a game over scene, and we can go back into our game and we can play it again. So now, if we got some points, and then got game over, we can now tap to play again, and the game will start completely again. So our difficulty system will go back to its starting values, and the score will go back to 0. So let's get a point. As you can see, we can play again as if it's the first time that we have played it. And now that we have our game over in place and we have a game over scene, that will let us move back into our game scene where we can play the game all over again, we now have a playable game. And this project is now very close to being finished. So that wraps up this video, and you have now made a fully playable game. All we have left to do now is polish everything off. So in the next video, which will be the 7th and final part of this series, we will add a main menu, we will add all of our app icons, and we will add a launch screen, which is the loading screen at the start of the game. We'll then take a look at a few different ways that you can take this game and you can change it to really make it your own. And that will wrap up this entire series. But for this video, that is all. I'm sorry it was such a long video, But as always, thank you for watching. As always, leave any questions or any feedback down in the comments. Hit like, hit subscribe, and I will see you next time. Goodbye.